All right, and we're rolling. Start out with any questions?
We had the discussions in like our classroom chat, and we thought it would be a better idea to turn the Master Center in person, Tuesdays,
Okay.
if that was alright with you.
It's gonna throw my entire grading plan off.
Yeah, because the labs are due Saturday, at least that's what it said on Blackboard, for the rest of the labs.
That's right, we did have that pattern going, didn't we? Except 33, because 33 is due 2 days before the final test.
Okay, then I guess that one we wouldn't have a choice, but to do
So,
it.
all right, so the next two due on Thursday, the lab's due on Saturday. And then Master Set 33, still due on the 27th, Tuesday the 27th, with the, and I'll get feedback to you, by sometime on Wednesday.
Would our test be 30 to 33, right, or 29 to 33?
30 through 34, and then 38, and I think it's 38.
Chapter 38.
Yeah, well, we're pretty much, I mean, if it was just through 33, then we've covered the material for the test, and the rest of it is just grading. Oh. Which is not necessarily a bad thing, but, no, there's still material.
What's chapter 38? For this?
Relativity.
Okay. And how does that relate to like electromagnetism?
It all stems from the idea of that the speed of light, electromagnetic wave, is constant regardless of the atmosphere in a vacuum.
Is that what we're learning today in chapter 20 or 38?
Yeah, or whatever the chapter is. Yeah, well, I figure we'll do just a little bit of AC and then we'll get into relativity. And basically teach you that everything you've ever thought was true is not. Yeah, relativity is one of those fun ones where at some point, there's gonna be some student who's going, that makes no sense whatsoever.
Math isn't on.
That's what we're hoping. Man, if those math people just weren't doing the long con all this time, we are sunk. All right. Any other questions or comments? I guess there was both then, just then.
Can I ask a question about the lab?
Yep.
Because on the instructions, like the PDF, it says, I think it's current versus voltage for
Right.
method 2. And then, on the Excel, on the spreadsheet, it's like current versus time.
Oh,
Which one do we follow?
do you have the spreadsheet brought up?
Yes.
I'd like to think that you didn't see something, but.
And then for number 23 here.
Turn on the line of S fit, so I equals something times, so that was current versus voltage.
Yeah.
Alright, so. Question is that it's numbered. The 17. I'm sorry. And I think I just put my thumbprint on your glasses. There's conflict with then. Oh, that's method 3. Since thin resistance, that's all right, that's from the table of current versus voltage right there.
Well, this is method one, I think. Wait. Oh,
So
yeah.
method two,
Sorry,
is-
method three, I meant.
so method three
Yeah.
would have been because the information they gave you was current versus voltage, so yeah, that should be. Oh. Yeah, that should be voltage and not time. Yeah, I did a cut and paste from down here, I must have done a cut and paste from down here, and forgot to change that. Alright, so in the method three, where I've got I equals, and then I have amperes per second times time, that should be amperes per volt times V, or delta V.
So that was,
It should be. So method three, you're doing, I gave you, or I didn't give you, you did the current and voltage, so you messed with the voltage and measured the current, and you got a whole bunch of data points here. So the equation should be I is equal to something amperes per volt. Times voltage plus something amperes. And I have time here, and that is amperes per second. In the spreadsheet, I have this, but it should have been that.
okay.
All right, any other questions?
For, the same lab, for the working resistance, it says pick one of the three.
Right,
Do we just pick any, or?
you can, yes. I mean, there's a certain little, I'm gonna use the word cheat, it's not really a cheat, you're gonna end up with three resistances, one is gonna be way out of, I think method two is just way out of bounds. The other two are very similar to each other. The method three I found is typically the best, comes closest to what the specs say. But if you whichever one you pick, I'm gonna base my grading on that one. So officially, there's no right or wrong answer, however, I find method three to be the most accurate. Assuming they didn't lie to us in the specs. Perhaps they're in cahoots with the math people and they've been lying to us all this time. 1 + 1 = 2, what kind of nonsense is that? Other questions? Anyone about to come up with a question? I will assume you speak for everyone, Marisol. Speak for everyone, you, represent, there we go, represent everyone. All right, let's see what you remember from last week. Because we had just finished doing a relatively complex AC circuit problem. Problem 70. There we go. And now for problem 71, which really by itself should not mean anything to you because it's in a textbook, which most of you, well, that textbook right there, which really helps, I'm sure. And eventually I'll come upon the problem. So everyone, all right. So it's basically, first off, what's the symbol mean? Yep.
Resistor.
Passive.
Resistor.
Inductor.
Inductor. The curls is the key there. Inductor has curls, resistor is just squiggles.
Oh, okay, that's it.
R, C.
Don't know why I said resistor.
We'll call it physics Tourette's.
Is this still in chapter 33?
Yes. All right. What's the impedance? This is basically what we're shooting for here. We've got a couple rules to go by. I know that X sub, so I've got resistance, X sub C and X sub L. Well, resistance is resistance, that R equals R. This is should hopefully not change your world a whole lot, but if it does, I'm glad I was here for it. X sub C. First off, what is X sub, what is the word? Besides grease.
Reactant.
What kind of reactance?
Ugly capacitor.
Okay, capacitive reactance is generally the way it's worded, but yes. What's it equal to?
1 over omega.
Okay, and the next one?
Omega L.
All right, and what does X sub L mean?
Inductance reactant.
Yes. Usually without the question mark, but spot on. All right. I know that, generally don't put the delta in front of it, it's just supposed to be one of those understood things. So V equals IR, that's potential across the resistor, and that is a V. Potential across the capacitor is, let's put serifs in there, I over XC, and V sub L equals I, X sub L. And then we have Eli the Iceman. So for an inductor, voltage leads current, and for a capacitor, current leads voltage. And what's the formula for impedance?
Epsilon naught divided by reactance.
No.
Depends on the circuit. Depends on the circuit.
That is true, yes. And that was what I was shooting for. However, let's take what Mario said. The units of reactance are the same as the units of resistance, which is the same as the units of impedance. So if I did impedance, if I did epsilon divided by one of the reactances, I would have units of amperes. So what is the sort of generic nondescript formula for impedance?
Isn't it?
Pardon?
It's gonna be different for every problem, but, isn't epsilon sub naught divided by, current?
Yeah, that's the other one. So it's epsilon sub naught, it's the voltage across the power supply, or magnitude of the voltage across the power supply, divided by the current coming out of the power supply. But the more specifics of it, the square root kind of thing that comes into it, that is indeed problem specific. And so that's what we're gonna try to figure out for this problem. So resistance, current, and inductance. This one should be easier than the one that we finished up class, with which we finished up class last time. So when you're doing this, phasor diagram. Now, where you draw the first phaser really is up to your own personal preference. I know that in the master set for chapter 33, I specified to draw the first phaser at, I think, either pi over 6 or pi over 3, 30 or 60 degrees, I can't remember which one it was. But I tend to do the first one in the first quadrant, just out of habit. So what is the first phaser I'm gonna draw down? What should it be?
Power supply.
What about the power supply? Alright, so recognize what ultimately needs to go into this. I've got 4 components here, each with a voltage and with a current. So I have 8 phasers I'm drawing down. Now, some phasers might be the same as others, in which case, I'll draw one and then I'll just label it with however many things that are equal to it. But officially, there's gonna be 8 phasers on my drawing here. So, let's start out with what is common. What is gonna be the same for, ideally, all of them?
Voltage.
So that's the first phaser to draw down. So label it with the magnitude of it. So epsilon, V sub R, V sub L, and V sub C. So that's 4 phasers right there. Half the problem done. All right. So I guess we're now left with the currents. What are the currents? And that's what we get into the leads, lags, or same, or in phase with.
For the inductor, the current is gonna be behind by by pi.
Pointing this way?
Pointing up and towards the left.
I thought you said it was behind.
Or counterclockwise. Are we going,
Phasers travel counterclockwise.
so down to the right?
All right. So by pi for 2. Did I miss the pi, p over 2?
I said pi, but I meant like 90-degree angle with
All
it.
right. My mind reading skills have been on the fritz since I have had kids. So
I said pi, but I meant like 90 degrees. I don't know why I said pi.
physics Tourette's. All right. Anyone in here have relatives with Tourette's? I don't mean to make fun of it, I'm just trying to make light of it. There's a distinction in my head, you'll notice. All right.
Is that a thing? Isn't that like a Tourette's voice?
Tourette's is the spontaneous, it's compulsion to do something without any control whatsoever. When I was growing up, Tourette's was the classic one was profanity. That you would just suddenly burst out in profanity, but it turns out it's any impulsive thing that you must do that's completely spontaneous and you have no control over it.
Sounds like ADHD.
Sounds like what?
ADHD.
I think there's more control with ADHD. It's more than just impulsive. It would be if in the middle of class I just suddenly came up with a string of profanity for no reason, just sort of happened.
Interesting.
That's my understanding of it. Fortunately, I've never had to deal with it, so my understanding is only from a bystander. All right. So that was the current of the inductor, and that is a right angle there. 3 to go.
Capacitor leads. The capacitor, the current's gonna lead, and it's gonna be 180 from high L.
All right. Do you want to make it longer or shorter?
Longer.
Okay. Two to go.
And for the resistor, the current through the resistor, it's the same same direction as the voltage.
Okay, absolutely. What's the official language of that, besides in the same direction?
In phase.
Yes.
What was that word, in series?
In phase.
Oh, in phase.
All right, and so now we're left with the current out of the power supply. Kirchhoff's rules still apply.
It's just sum of all the.
Yes. Because the current coming out of the power supply will then split. And so the sum of these three currents has to equal the current coming out of the power supply. And so we are going to add these three phasors. We add them like vectors. And we'll go for that stunning visual effect here. So IC is longer than IL. If you have it IL longer, that's fine too. You're ultimately going to square something here, so it doesn't matter which one you pick. So this would be IC minus IL. So that's the sum of those two phasors, and then we're going to add in the resistance phasor. Again, you add them like vectors. And that's I sub, that's I sub power supply. It's the sum of the three phasors. The dotted lines are supposed to be like parts of a rectangle there. I'm not quite sure I quite made that, but. So I know that I of the power supply equals, squared is equal to IR squared plus IL minus or I guess the way I did it, IC minus IL squared.